Welcome to day 6. You've got day 6 homework for your planners. Also, you've got problem set to be working on, which is due on day 8. Make sure to be working through that. Remember, on the back of the problem set, there are the units and days you could look at on Schoology if you are stuck and unsure how to do the problems. And we're going to pause the video for 5 minutes to give you a chance to do the warm-ups. All right, the first one we have our crisscrossing to make an angle that's not at the center. So we always want to have our angle is equal to 1/2 of arc plus arc. And the two arcs should be the arc that the angle opens up to, and the arc that its vertical angle opens up to. So this is really half of 126. So we should have gotten an x of 63 degrees. Two ways you could have figured out number 2. You could have done half the 280 is 140, and then angles on a line add to 180, so x is 40 degrees. Or you could have taken the 280 for the arc, and the other arc would have to be 80, because they have to add the 360, then take half of the 80 to get the 40. And then in 3, it's our angle outside the circle, so our angle is equal to 1/2 the bigger arc it opens up to minus the smaller arc. So this is really 1/2 times 116. So in other words, x is equal to 58 degrees. All right, moving over to the homework. Letter A, outside the circle, so half big arc minus small arc, you get 20. Same setup in B, 1/2 big arc minus small arc, you get 67. And then in C, it's our tangent chord, so it's really just a special inscribed angle. So either 46.5 degrees, or if you had it as 93/2, that would be fine as well. D was like the first one in the warm-up. So your angle is equal to 1/2 arc plus arc. And it's the arc that the angle opens up to and its vertical angle opens up to. We get 90 degrees. Here our outside angle, the 70, is equal to 1/2 the bigger arc, which was x, minus the smaller arc, which was 40. Divide by half, which is multiplied by 2, you get 140. Add the 40 over, so you get our big arc there is 180. The angle outside 50 is equal to 1/2 big arc minus small arc, so 201 minus x. Divide by half, which is like multiplying by 2. Subtract the 201 over, you get negative 101, and divide by the negative 1, you get 101 degrees for x. Our angle 61 is equal to 1/2 of arc plus arc. Multiply by 2, which is like dividing by the half. Subtract the 87, you get 35. Because O was our center, because we had circle O, that angle there is 80, so then angles on a line add to 180, so x is 100. In I, we have the outside angle is equal to 1/2 big arc minus small arc, so we got 27. We have crisscrossing lines inside, so the angle is equal to 1/2 arc plus arc, where the arcs are what the angle opens up to, and its vertical angle opens up to, so we eventually get 140 when we go through and solve that. The major arc should be double the 115, so 230. The minor arc's the leftover to get to 360, so we had 130 degrees. We wanted to find AB, so we start with our angle, the 45 equals 1/2 of big arc, the 150, minus the small arc, which we didn't know, I called it x. Divide by half, which is multiplied by 2, subtract the 150 over, and divide by negative 1. We eventually get the arc we're looking for is 60 degrees. We want to find AB. So again, we're outside the circle. So the angle 40 is equal to 1/2 big arc minus small arc. Divide by half, which is multiplying by 2. Add the 50 over, you get 130. In E, because there's only 2 arcs, if the one is 230, the other is the leftover to get us to 360, which is 130. I called our angle we're looking for x. That's equal to 1/2 big arc minus small arc. So we got 50 degrees. And then F is our tricky one like we saw in class. So I called the minor arc X and the major arc 360 minus X. So the angle is equal to 1/2 of the big arc minus the small arc. Go through and solve for X, again it's 125, but note that was the minor arc. So 360 minus 125 then gave us 235 for the major arc. Okay, so there's no new things today. Today is kind of putting all things together and recognizing our different scenarios when we come across them. So we're going to start on page 42. So first off, naming a central angle. So a central angle should have its vertex at the center. The center can be identified by what the circle's name is. They told us the circle here was circle A. So if we were to name a central angle, we would just have to name some angle whose vertex is at A. So for example, one option would be angle EAB. Could do EAC, CAD, BAD, all those would be fine as well. An inscribed angle is an angle whose vertex is on the circle. So an example of an inscribed angle would be CED, because E is on the circle. You could do CFD, CBD, you could do ECF, ECB, EDB, FDB. So there's lots of different options there. A chord is a line segment whose endpoints are on the circle. So we've got a whole bunch of chords there. They want us to name one that's not a diameter. The diameter must go through the center. So we've got to find a line segment whose endpoints are on the circle, but does not go through the center. So one example would be EC. Other examples would be FC, FD, and BD. I think those are the only other ones that have endpoints on the circle but do not go through the center. And then CAD's measure, well, CAD is a central angle. It's opening up to the 56. Central angle's measure is the same as the arc it opens up to, so just 56 degrees. Working with the same picture, angle CBD is here. That's an inscribed angle, so it should be half the arc that it opens up to. So trace the sides of your angle, and notice it's opening up to this arc. So the angle should be half that arc, so half of 56 will just give us 28. And we want three angles of equal measure. So usually what you're looking for in a question like this is you want inscribed angles that are opening up to the same arc, because they would all be half the same thing. So notice CED, that inscribed angle opens up to the 56. So it would be half that, the 28. CFD is also an inscribed angle that opens up to the 56. So its measure would be half that. And then the one we did up above, angle CBD, we know also opens up to the 56. So its measure would be the 28. And lastly for this one, arc CBD. So we want to go from C to D, but we got to pass through B. So we're doing this arc here. Well, we have the missing arc is 56, so we can just do 360 minus 56 to get what our value would be. And that should give us 304 degrees. All right, moving over to the next page, we're going to see if we're going to pause for 1 minute and see if you can do parts A, B, and C. So in this case, we only had one option for a central angle. We'd have angle CAD, because they told us it was circle A. Now you could have called that DAC, and that's the same thing. An inscribed angle, we have two options. We have angle CBD, Or you could have done, or three options, I guess. So angle CBD, you could have done ADB, or you could have done ACB. Any of those three would be fine for inscribed angles. Chord, we only had one option because the endpoints have to be on the circle. So CB, or you could have called it BC. Oh, I take that back. There's two options. BD you could have done as well. So CB or BD would be your options for the chord. All right, so for a minor arc, it has to be less than 180. So an example for that might be arc CD. We could also do DB. We could do arc CDB. All those would be fine. And a major arc, we could say arc CB here, because this is over half a circle. Now they told us in the question that CAD, our central angle is 50. Well, that's opening up to arc CD. Your central angle is the same as the arc it's opening up to, so that's just 50 degrees. CBD wants us to start at C and get to D by passing through B. Well, that's just our leftover in the circle, so 360 minus 50 would give us 310 for that. And then angle CBD is right here. That is an inscribed angle because its vertex is on the circle. Inscribed angles are always half the arc they open up to, so we should have 25 degrees for that one. All right, so we're gonna pause the video for about 5 minutes to let you, no, we'll say 4 minutes. We're gonna pause the video for 4 minutes for you to try both of these. If you are unsure of them, look back at what we did on the first one on the warm-up. Okay, it should be very similar because we have crisscrossing lines in the circle that are not crisscrossing at the center. So again, we're going to pause for 4 minutes to allow you to do 3A and 3B. All right, so we should have our angle is equal to 1/2 times the arc our angle opens up to, plus the arc that the vertical angle opens up to. This is just half of 160. So we should have got 80 degrees. And same idea on the next one, the angle is equal to 1/2 the arc we open up to plus the arc the vertical angle opens up to. So this would be half of 63. So you could either write that as 63 over 2, that would be fine. Or this is 31.5 as well, degrees. All right, we're going to do these ones together. They get a little bit more complicated. So in 4A, we should be able to find x right away because angles on a line add to 180. So we know that x plus 121 should equal 180. So if we subtract the 121 over, we should just get 59 degrees. So that's half of what we want to know in this question. Now for the other half, we should be able to do what we did a second ago, just our variable will be in a different spot. We always start with our angle, equals 1/2 the angle or the arc that we're opening up to plus the arc the vertical angle is opening up to. We'll divide both sides by 1/2, and we've seen that dividing by 1/2 is the same as multiplying by 2. So this is going to give us 118 equals 42 plus y. So we want to subtract 42 from both sides. And we should end up with 76 for y. and that's degrees. So we still got our crisscrossing lines, same setup, it's angle equals 1/2 arc plus arc. Just wherever you're missing, put the variable in there and then solve for the variable. Well, in this one here, notice we do have crisscrossing lines. There's an x here, and we would use these two arcs. One of them has an x. But we'll set things up the same. So we'll do x equals 1/2 arc that we're opening up to, plus arc for our vertical angle. We can divide both sides by 1/2, which is the same as multiplying by 2. So we'll get 2x equals 3x. Then I'm going to combine some like terms here. Negative 68 plus 34 would just give us negative 34. If I subtract the 3x over, that's going to give us negative x equals negative 34. We can divide by -1 to just get that x is equal to 34 degrees. So if we go back up, this is 34. We've got another angles on a line scenario. So we know that 34 plus y should equal 180. Subtract the 34 over, and we just get y is equal to 146 degrees. So even though we've got all our circle rules from this unit, don't forget things like angles in a triangle add to 180, angles on a line add to 180. They still come into play in these problems. All right, we're going to pause for another 4 minutes for you to try these ones. If you're unsure, look back at our warm-up, question 3. Should be pretty similar to what we did there. So again, we'll have you do 5A and 5B, and we'll pause for 4 minutes for you to try that. So both these had angles outside the circle, so we'd have x equals 1/2 parentheses. The big arc it opens up to 82, minus the small arc it opens up to 26. So that's x equals 1/2. This would give us 56 inside. And then 1/2 of 56 is just 28 degrees. And you can just punch that whole right side in the calculator if you want as well. So here we're going to have our angle outside is equal to 1/2 times the big arc minus the small arc. But we don't know the small arc. We can figure it out because there's only 2 arcs. So 360 minus 252, that would give us 108. And now you can either just punch this all in the calculator or go through and do it by hand. So this is going to give us 144. And then 1/2 of 144 is just 72 degrees. All right, so there's 2 things we want to find. We want to find angle DFG, or DFE, sorry. So I'm going to go ahead and call that X. And we want angle DGB. I'm going to go ahead and call that Y. Now notice they didn't call this circle G, so we don't know anything about G being the center, so we got to assume that it's not the center. So sometimes with circles, just start labeling things that you know. Because that 25 is an inscribed angle, we know it is 1/2 the arc it opens up to. So the arc it opens up to must be double it, so that's got to be 50. Well, if we know the angle outside the circle, that angle outside the circle is open up to the 50, and then this thing that we don't know, let's call it Z. So what we could do is we could figure out what Z is. So our angle outside is 42. That's going to equal 1/2 of whatever Z is minus the 50. We'll divide both sides by a half, which is the same as multiplying by 2 to get us 84. And then if you add 50 over, we'll get 134 for z. Well, notice our angle that's x is an inscribed angle because its vertex is on the circle. And it is opening up to arc DE, the one we just found. So therefore, x is just going to be half that. So if we do 134 divided by 2, we'll just get 67 degrees. Well, because we now know that's 67, notice that's 2 of the 3 angles in triangle GFE. So we could do 180 minus 67 minus 25, and that can give us the third angle in the triangle. Well, this is really 180 minus 92, so we'll end up getting 88. Well, if that angle is 88, y is just the vertical angle of that. So y would just equal 88 degrees as well. So kind of like we talked about angles in a triangle adding to 180, angles on a line adding to 180. Those were not new this unit, they're from previous units, but they come up in these problems. Also be on the lookout for vertical angles. Not new in this unit, but something that can be helpful. All right, our last one for this video, number 7, we want to find FGE. Well, let's label that a variable that's not in the problem. We'll call it x. FHE, we'll label that with another variable, we'll call that y. Well, it doesn't look like we have stuff that can directly get us any of these, because x is inscribed. We would have to know arc FE to know what x is. Y is crisscrossing in the circle, so we'd have to know these 2 arcs to figure out what y is. So we don't have enough yet, so just start labeling stuff you might know based on the other given things. Now, one you want to jump to is that 28. 28 is an inscribed angle. It's opening up to FE, so the 28 should be half of FE, so we should get that this is 56. Well, now that we know that's 56, x should just be half of that. So x is also going to be, oops, not 50, x is going to be half that, so 28 degrees. Well, let's do kind of like we did on one of the other ones. Let's call this z. Our angle outside is 40. That should equal 1/2 of the big arc it opens up to, which is z, minus the small arc, 56. Because remember, you want to think of that angle outside as like a big mouth, and which arcs are inside the mouth. Well, we'll divide by a half, which is multiplying by 2, which will give us 80. And if we add the 56 over, we get 136 is equal to z. Well, now we have the things that we need to find y, because y is crisscrossing inside the circle. So our angle y should equal 1/2 the arc it opens up to, the 56, plus the arc that its vertical angle opens up to, which is the 136. Now you can either just type that in the calculator, the right side there, or if we did it by hand, that's going to be 192. And half of 192 is just going to be 96 degrees. So that's it for this video. You got day 6 homework you can be working on. You also got problem sets going to be due on day 8, so you can be working on that as well. Any time left in the period, you can work on either of those two things. Have a great rest of your day.